In this video I'm going to introduce the concept of inheritance with respect to the tkinter frame class. Let's consider this computer program here, and we can see on this line that we're creating an instance of the frame class. If we look in the brackets, we can see we have things like this. Height is assigned 150, width is assigned 150, relief is assigned raised, and so on. Now, if we consider what this means, height, for example, well, that's going to set the height of the frame, but I'm assigning 150 to height. Now, this means within this class, which I haven't got access to, I can't see inside it because I'm not the programmer of the frame class. It comes with tkinter. But I can say with some confidence that within it, it has something capable of storing this 150. You see, the 150 will be transferred to this, which is defined inside this class. So here, for example, I'm passing in raised to relief, and I can say that inside the definition of this frame, there'll be something there which is capable of receiving raised. Here, you can see BG, which is background color, it stands for background color, is assigned red. So inside this frame, there is something capable of receiving this red. So when I refer to these options here and say that the values I'm passing in are assigned to something inside the class frame here, what we really need to think about is this. Yes, frame does have all of the definitions of the things that are going to store these values, but what we're doing on this line is creating an instance. So it would be fair enough to say that height of 150 will be given to this object. And when I say this object, remember frame underscore A in this case is bound to an instance of this class, i.e. this is bound to an object of the frame class. Now, if we look at this line, we're creating another instance of the frame class, and this instance will be bound to this name frame underscore B. And when we consider all of the options here, what we need to realize is that this value here of 150 for the height will be given to the object that this is responsible for referencing. So this one here, for example, which is a relief equals sunken, that will be given to this instance. So frame A and frame B, although both of them are based upon the frame class, internally they will have different values, as shown here for the relief and as shown here for the background color. They just coincidentally happen to have the same height and width and the same border width. But what we need to appreciate is that this line creates an instance that is bound to the name frame underscore A. This is creating an instance that is bound to the name frame underscore B. And these values, well, these are the options whose values are sent to those instances of the frame class. Let's now consider this line, and we can see we're referring to the instance of the frame class that's referenced by the name frame underscore A, and we're invoking the grid method, and this will position this frame at row 0, column 0 of this window. Why this window? Because that's the window we passed in here when we created the instance of the frame class. And this one, well, we can see that's going to position the other instance of the frame we created at row 0 and column 1. So when we look at the runtime for this program, what we're going to see is this. And as expected, if you look at both of the frames, you can see they're the same size, 150 by 150. If you look at this one here, you can see that that is red. Now, the reason it's red is because we set BG here to red. And we can clearly see that this one is green because this one here has been set to green. And if you compare both of them, you can see that this one is raised and this one is sunken. And that's because we can see here we have the relief of each being set to something different, i.e. raised and sunken. This one we can see is in row 0, column 0, which is what we did with this line of code. And of course this one is in row 0, column 1 because of this line of code here. Now if we consider what we've just done, we've taken the frame class, and if we look at the execution space, we know we're going to be creating an instance of a frame, and we're creating another instance of the same class. And when we saw the runtime, we got this. And the fact that these frames look slightly different, it's because the attributes of this one and the attributes of this one have been set differently. Clearly we can see one's red, one's green, and one's raised, and one is sunken. So when we look to these two instances here, these two objects, this one has its background property, for example, set to red, whereas this one has it set to green. They both have the same size, so inside here, this one has its own copy of 150 for the height and 150 for the width, and this one here has its own copy of 150 for the height and 150 for the width. Now that's key to understanding object-oriented programming. You see, we're not saying this stores the 150, the instances store the 150. This instance stores the colour red, and this instance internally stores the colour green. So when we talk about creating instances of frames, we can see that we have the same kind of widget on the screen. It's just that we've set them up to look slightly different. Let's consider the frame class for a moment. Now this is something that comes with tkinter, and you've seen how we can use it. I've created a red and a green frame and put them on a window. Now what features this frame gives us, I would have to look up in the help and simply have a go at doing a directory function on the frame to see what attributes it has. I'm not responsible for coding this frame, but I am responsible for using it as the programmer. If I decide, however, that the frame doesn't quite give me everything I want, because remember we can use the frame class, the frame object, the frame instance, to build up complex widgets that will contain a button, a label, and various other methods tied to it that will perform some kind of task. If I therefore see this as the basis of what I require for one of my applications, I can decide to create my own frame, which I'm calling my frame, that I'm going to give properties and methods to. But the key here is we can have something referred to as inheritance, and inheritance is shown by this open-headed arrow here, meaning that my frame inherits from frame. And in this area, I now can add properties and methods. The key here is that this will have all of the properties and methods that have been defined here. So if this has X number of attributes, this has at least X number of attributes, plus all the additional ones that I as a programmer decide to add to my frame. Let's consider the terminology surrounding the use of inheritance. When we look at this diagram here, we can see that my frame and frame are example of classes, and my frame is inheriting from frame. Now when we have this relationship, it is usual to refer to this as the superclass and this one here as the subclass. So my frame is the subclass because it is inheriting from frame, and frame is the superclass as it is being inherited from. Other words used to describe this relationship is parent class and child class, and you will often hear the term base class and derived class. This is one, for example, that's used when discussing VB.NET. When we're dealing with Python, I recommend that you go with superclass and subclass. Now the relationship you can see in this diagram is dealing with classes. My frame is a class and frame is a class, and my frame is inheriting from frame. What we need to appreciate is my frame is a class, it's not an object. So if we consider the execution space, what we need to realize is if I wish to use the frame that as a programmer I am going to create, i.e. the definitions inside the myFrame class, I will want to create instances of that class, and here you can see I'm producing two instances based upon the myFrame class. And what's important is that both of these instances will be able to have access to the attributes that we declared in this class here, and the additional attributes that were defined in this class by me as the programmer. So these two have at least all of the attributes declared here, plus the attributes declared here. But it is important to realize that you do have this class relationship, but we then still produce instances of the class that, as a programmer, I'm responsible for creating based upon the frame class that was given to us by tkinter. To emphasize the point, let's consider the frame class, the one given to us by tkinter, the one as a programmer I can use. But I now decide that I want to build up an application based upon this class, and I decide that this is going to be called my frame, and it's going to inherit from frame. If I now look at the execution space, as the coder, I can decide that I want to create an instance of the frame class, the thing that tkinter has given us, and I'm going to create another instance. But equally, I can create instances of my frame, the class that I was responsible for coding, and I'm showing two being created. Now there's things here that we need to consider. You see, this object is based on this class, likewise this one. This will have X attributes. What we can say about this object, it will have at least X attributes. It will have all of the attributes that this one has, but this one will have all of the additional ones that were declared in here by me, the programmer. Now that means that this class here that I'm coding, I could add buttons to, labels, methods, and I can have an application built up in a frame, and I can then position that frame on a window. So whereas we're looking at the execution space here and looking at a number of objects, these objects are related to each other by the inheritance that you can see in the class diagram. These two have identical attributes. These two have at least all of the attributes these two have, plus the additional ones that are declared in here by me, the programmer of this class. Before we look at how we can implement inheritance in Python, let's just have a quick look at this computer program here. On this line you can see we're creating an instance of the frame class. Now I can show that by taking the diagram here to represent the class frame. Now what we're doing, if we have a look at these brackets here, we're setting the height to 150, the width to 150, the relief to raised, the border width to 8, and the background color to red. The key, however, is that this creates an instance of the frame class, which I'm showing here appearing in the execution space. Now, of course, when we look at the runtime, what we're going to see is this, and we can see that the frame has been added to this window where the window was created on this line and passed to the frame here, passed to the instance that we're creating at this point. And of course here we can see we've set the height to 150, the width to 150, and if we have a look, the background color is red, and we can see the background color of the frame is red. Here we can see that the relief is raised and the border width is 8. To introduce inheritance, I'm going to take the frame class, the one that's given to us by tkinter, and I'm going to produce my own frame class called redFrame, and it's going to inherit from frame. And the desire in this case is to allow me to create instances of the red frame that give us exactly what we saw a moment ago, a frame that appeared on a window in a red color as its background, with a raised relief and a border width of 8 and a size of 150 by 150. Now clearly I could do that by creating an instance of the frame class and passing in the appropriate values. However, I want to achieve this result using inheritance. So what we can see here, I have two classes where one is the superclass and the other is the subclass. And if I want in Python to set up this relationship, I do it as shown here. I use the word class. I then choose the name of my choosing as the programmer red frame, taken from the diagram here, and in brackets I put the name of the superclass, which is frame, which is this class. So here what we can see, this is the subclass and this is the superclass. So the red frame inherits from this. This is the subclass, that's the superclass, and of course, as we always have in Python, we will see the need for this colon here. So when we wish to create a relationship that is inheritance, this is how you do it. You have the name of the subclass here and you have the name of the superclass here. What I want the code to do is to create this relationship and then create an instance of the red frame class, which I'm showing in the animation as you can see here. I create this instance, which is going to be based on the red frame class, which as a programmer I'm responsible for producing, and of course the red frame class is going to be based on the frame class, where the red frame is the subclass and the frame class is the superclass. Now at runtime what I want to see is this, and you can see that the frame has got a red background, it's got a relief that's raised, it's 150 by 150 and the border width is going to be 8. But to be clear, this frame is going to be an instance of the red frame class, not an instance of the frame class with various values passed to it. I wish this frame to be an instance of this class, the one that I'm going to code using inheritance. This is the code for the red frame class. Now I'm going to come back and describe this in a moment. What I now wish to do, however, is just to come down here and have a look at what we're doing, and you can see that frame underscore A is assigned red frame, and in brackets we've got my window. Now what this line is doing, it's creating an instance of the red frame class, the class that as a programmer I've been responsible for producing. Now I just want you to compare that with this line of code here, and you can see that's how we created an instance of the frame class. And if you have a look, I'm using the same name here, frame underscore A, and in brackets you can see I'm passing in my window. But have a look in this region. You see there's nothing being passed in to the creation of the instance based upon the red frame class, whereas here you can see we've passed in quite a few things: the height, the width, the relief, the border width, and the background color being red. And then here of course you can see that we're positioning the instance of the frame class, whereas here you can see we're positioning the red frame in exactly the same position as we placed it when we run the program, as shown by these two lines of code. Let's now turn our attention to this class here, which is the subclass, and you can see it's called red frame and it's going to be inheriting from this superclass. Now when as a programmer you decide to declare your own classes, you have to realize that you need this method here, and this is the double underscore init double underscore method, and you can see that we have the def and we have the colon here, and have a look in brackets and you can see there are two parameters. Now one of them is self and the other one I've called the underscore window. Now self I've covered elsewhere on my YouTube channel, and it's very important when you're dealing with classes, as you know what this is. Now I am going to explain it here, but a fuller explanation appears elsewhere on this channel. What I wish to do now is to come down here and have a look at how we create an instance of the class. Well, the instance is created by using the name of the class, and then you can see I'm passing in my window. Now my window is the window created on this line, and we pass it in here so that the instance of the class knows to which window it is going to be associated, and this is passed to here, to the window. So the instance of this class knows what window it's going to be associated with, because whatever the identity of this is passed to here. This is the reference to my window, and that reference is passed to here. Now what is self? Well, whenever you create an instance of a class as shown here, automatically and not seen as a parameter in the brackets here is the ID of the instance created on this line. So this receives the ID of the instance being created, and it means that the code in here now knows which object it belongs to. Now this is handy because we can create lots of instances of this class, and each instance will have its own ID. So this will therefore be representing the ID of all of those instances. So instance 1, so to speak, the ID will be held by this. Instance 2, the ID of that instance will be held by this. To avoid getting too bogged down with the details, regard each instance as having their own copy of this. So this is the class, and this is the initialization routine for this class, and every class needs one of these. And this line creates an instance of the class we're considering. And when that instance is created, this receives the ID of that instance. And we can see that this self is used here in the code. Now that means we are referring to the current instance that's been created, the current instance of this class. This is the argument that's passed to here. Now that means that the current instance knows which window it's going to be associated with. Now when the instance is created on this line, the code that will execute next is this lot here, and of course we'll be dealing with the current instance as specified by this self. If I go to this line first, you can see that this is saying for the current instance, what I wish you to do is to set the height to 150. This is saying with the current instance, set the width to 150. This one is saying set the relief to raised, the border width to 8, and the self, i.e. the current instance, background color is going to be set to red. And if I go back to this one, you can see this is referring to the current instance. Here you can see I've got the square brackets, and in the square brackets I've got the height, and I'm assigning that the 150. Now the question you need to ask, where does this height come from? How come I'm able to gain access to the height property for the frame? Because that's really what this line is saying. Well, the reason I can get at this is, if you remember, this class, which is called the red frame, is the subclass of frame. Now because it's the subclass, it has access to whatever is defined inside here. So it does have access to height, to width, to relief, to border width, and to the background color. So as the programmer of the red frame class, I've not been responsible for creating the height, the width, the relief, the border width, or the background color. Because of inheritance, I'm able to access these directly from within the instance of this class, because this class has inherited from the frame where the definition of the height, the width, the relief, the border width, and the background color were initially set up. To ensure we set up an inheritance relationship between the red frame class and the frame class that was part of tkinter, we have to insert this line of code within the initialization routine of the red frame class. Now what this line of code is responsible for doing is invoking this initialization routine that is part of this class, part of the superclass. It's not one I've been responsible for coding. It comes with the widget, the frame widget, that's defined inside tkinter. Now this here is a super method that allows us to gain access to things that have been declared in the superclass. And of course the superclass in this case is the frame class. So ensuring access to height, width, relief, BD and BG, it's not sufficient simply to have this line of code here where this is defining the superclass, and this obviously by definition is the subclass. We have to have this line of code here. So let's walk through the execution of this program. This creates the instance of the window, which we then pass in here, and this line creates the instance of the red frame class, which means that this will execute. The first line to execute is this, which executes the initialization routine of the superclass, And here we then find ourselves setting the height, width, relief, border width and background color appropriately for the instance of the red frame class. Then this line, well, what it will do, it'll position the instance we've just created that we have bound the name frame A to, and it'll position it in row 0, column 0. So what we should see when the program executes is this. There's our red frame within the window, but we must be clear that this red frame has been based on this class here. And this class, we set the various properties of the instance with this bit of code, and of course we then positioned the instance using this line of code here. It is important that we don't get these two lines of code confused with the two we've seen before, i.e. these two, where here you can see we're creating an instance of the red frame and here we're creating an instance of the frame. And when we created the instance of the frame, we can see that we set the values here, whereas when we created the instance of the red frame, there was no setting of values in these brackets. The setting of the values was done inside this definition because through inheritance we were allowed access to the various attributes that were defined within the frame class. Let's now consider this computer program, which is almost identical to the one we've just considered, except I've now got two additional lines of code. The first line is this one, and this is going to create another instance of the red frame class, and this line is going to position that instance. So if we have a look at the runtime for this program, what we will see is this, and we can see we have two red frames. This frame is this one here, positioned by this line of code, and this one is the instance created here, positioned by this line of code. Of course, this class being built here is in fact not very useful, is it? All it's doing is giving me the ability to produce a red frame of a certain size with a 3D look. Of course, frames are used to build compound widgets, and what I mean by that, you take a frame and you add to it some entry widgets, some buttons and some labels, and you click on a button and some processing takes place and the results are displayed in a label from data entered via an entry widget. And then what you have is a frame being built into a class that inherits from the frame class, and then you can position that subclass, the instances of that subclass, on your window where you like. Now, I'll be looking at how you do that in some videos that are coming up in this playlist. Let's consider this computer program, and you can see here I have the same definition of the red frame class, and it's inheriting from frame. So red frame is the subclass, and here I create 4 instances of the subclass, and here I position those 4 instances, and what you can see I will have is this. And you can see there are 4 frames, each positioned appropriately. And each frame that you can see in the runtime is based on the subclass that's been called red frame. Let's quickly look at this computer program, and you can see I've got the same class being declared here, the red frame class, which inherits from frame. And on this line, I'm creating an instance of that class, and this line I'm positioning it. But here I'm creating an instance of the frame class, and I'm setting its values to this, and I'm positioning it with this code here. And then I'm producing an instance of the red frame class, and then I'm positioning that one with this line of code. And then I come onto this, which creates an instance of the frame class with the appropriate value set here, and then I'm positioning that with this. And of course, when I look at the runtime, this is what you will see. And these 2 widgets were based upon the red frame class, and these 2 were based upon the frame class with the appropriate values passed, as you can see in the code here. What we've seen with the last program is this. We had the frame, and we created a red frame that inherited from frame. And then if we look to the execution space, we created an instance of the red frame, then an instance of the frame, then another instance of the red frame, then another instance of the frame, and then these instances, these objects, were then positioned onto the window, and you can see that illustrated here. If you look at the 4 objects that exist in the execution space, it's important to realize that they all have their own copy of the attributes that have been defined in their respective classes, i.e. the classes on which they have been based. So these 2 here, for example, have the same attributes that are defined in here, but they're not in this case, they can be set up to be different values. These 2, well, they are 2 objects that are based upon the red frame class, and they have their properties set as appropriate. Each of these objects will have the self parameter identifying them uniquely. So this one will use the self that was declared in the initialization of this class, and this one will have access to that self that was declared in this class. But the values that are in that self are different. This one has its own ID, and this one has its own ID. Check out the supporting website for these videos. In addition, why not follow me on Twitter, as I issue a tweet every time I upload a new video.